Hello and welcome to this demo of the Fabric Data Science Copilot. In this demo, we will be exploring how to use Copilot to empower your data scientists when analyzing data and building machine learning models. To begin our demo, we are in a notebook connected to a lakehouse where we have a table called heartdata containing our training data for the experiment that we wish to conduct today. We will start by loading this data into the notebook. When we open the Copilot pane in the notebook, we see some prompt suggestions right here. Let's pick the first one, load data from my lakehouse into a data frame. We are going to specify load the hard data table, and Copilot will generate the required code for this action. Once Copilot has generated the code, we can simply move it over to our notebook in a new code cell, and we can execute this code. We now have loaded the hard data table into our notebook as hard data df, and we can see a visualization of our data right here. We can now move back to these suggested prompts in Copilot. Actually, you can also access them from here, from the bottom. And the next question we're going to ask is to generate insights from this data. We will analyze our brand new hard data df, and we will see what Copilot returns. We can now see that Copilot has generated some code for us to run that will explore different characteristics of our dataset. Let's move over this code to the notebook so we can execute it. From what we see that Copilot is showing us, we see well-commented code explaining step by step what we are trying to do in these different functions. We can see our structure, our different columns, and some summary values. But this sometimes is a bit hard to see. So what we can go ahead and do is ask Copilot for a natural language explanation of what is happening in the previous cell. I would now like to show you the use of cell chat magics. Chat magics are commands that you can run directly on cells where you can query Copilot from a code cell and reference previous code cells and get your answers straight in the notebook without having to use the chat side pane. To execute one of these chat magics, we will enter 2% signs and chat, and in a new line below, we will ask our message to Copilot, in this case being based on the previous results. What can you say about the structure of our data? Yeah. We can see now that Copilot has given us an explanation in natural language of the previously outputted code. We see that we have 1,028 rows, the 13 different columns, and these are very easy to understand explanations of why these columns are of interest to us. So this is really the first step in data analysis, is trying to understand what our data set contains so that we can make good decisions on what to do next for our machine learning experiments. We can see that from this output here, Copilot has determined that there are 3 columns that have missing values, and Copilot is also talking to us a little bit about the distribution and the numerical distribution. At the end, we can see a summary where we see a well-structured mix of numerical and categorical features relevant for heart disease analysis. There is some missing data, but the dataset is suitable for statistical analysis and machine learning regarding heart disease prediction or exploration, which is basically what this dataset was built in. So this is a very good explanation by Copilot. Now let's try to look at a specific visualization of something we are interested in this data frame. I will ask Copilot again on the chat pane to show me a histogram for the distribution of age in heartbeat. We can see that Copilot here has generated some code to create this histogram for us, and we will go ahead and move it over to the notebook once more. And we can now see our age distribution on this histogram, and we can see the frequency is most common between the ages of 50 and 60 is where we have most of our records. Now that we have obtained this key information about our data set, we want to ask Copilot what are some next steps, what is some more visualization we could do on this data set to uncover some insights we might have not thought about. We can see that Copilot has generated a list of different interesting visualizations that we could generate, including histograms, box plots, bar charts, and more. You can also see that for each case, Copilot has listed the different columns that can be of interest for this specific kind of visualizations. Copilot is also asking us that if we want to see any of the specific visualization, it can generate the code for us. So let's go ahead and ask for box plots, bar charts, and stacked bar charts. I will just ask Copilot to generate the code for 2, 3, and 4. Copilot has generated the code for the 3 different use cases we have asked, and now let's go ahead and run this code in our notebook. Now that this code has finished running, we can see all our different visualizations. The first one exploring the age distribution of heart disease status for those patients with no heart disease on the left and with heart disease on the right. I would like to point out we have 4 outliers clearly marked at the bottom of young people with heart disease, but we tend to see that the older you are, the more likely you are to have a heart disease. Here we also see the frequency of sex in the data set. We can see we're dealing with many more males than females. Therefore, this might be something we want to look into when we are generating new data for our experiments. And finally, we have the different types of chest pain, and we see that this kind of chest pain is the most frequent in our data frame, but this chest pain in this case has more cases of not having heart disease than having heart disease. In this case, we have the 1 and the 0. But really what we're trying to get at here is that Copilot can guide us through natural language in terms of what we should be doing to analyze our data frame, as well as generating the code for us to actually see this firsthand. This is very helpful because it's not just generating a lot of visualizations without us knowing what they're about, but it's actually giving us a clear explanation on what we could look at in each visualization and just giving us the option of running them or not, as well as in this case, explaining the results of the statistics generated by the data frame. I want to now go ahead and with the missing data that Copilot has identified, I want to deal with those columns, with those missing values, because we will not be able to train our data set, our machine learning model without clearing those missing values. So we will go ahead and create another chat magic in this case, and we will ask Copilot, how can we deal with the identified missing values? We can see that Copilot is returning another natural language explanation of what we can be doing in the context of the missing values it has identified. We can simply remove the rows. We can input missing values such as mean or median, mode, or domain-based if we have specific medical knowledge to fill those missing values. We can use another machine learning model to fill in these missing values based on predictions. So if we train a model, we could also use it to fill in these missing values, but this is one of the more complex options as Copilot is letting us know here. And we can just flag these missing values if we have a model that admits them. But in our case, we will not have that type of model. So we will just be doing our first step of removing these rows to keep it simple. It also is giving us a recommendation if the missing values is low in our data 10%, mean and median imputation is often practical for numerical columns. And if I just want to avoid imputation bias, I can just drop those rows. Copilot will let us know if there was about 90% of missing data in this case. It will probably let us know that this approach of dropping missing values is not going to be helpful, given that we're going to be taking away most of our data set. But again, I really like this approach of explaining to us what our options are instead of just generating code for them. Now that we have been using chat magics, I would like to show you how you can use in the code version. When we ask Copilot %% chat, we are going to be expecting a natural language output, but when we do %% code, we're basically flagging to Copilot, okay, in this case, we don't want you to be verbose, we just want you to generate this code. So I would like to go ahead and drop all rows with missing values as outlined in option 1. Now that we have removed all values from our data frame, a teammate has provided me with a code cell that they tell me is important to run before I start any machine learning model. Let's go ahead and introduce this code cell into our notebook. However, my teammate has not been very specific about what this code cell is doing, so we can go ahead and use Copilot to generate an explanation. On the top right-hand side of this cell, you can see a Copilot icon. Let's click the Copilot icon, and it will open a new tab here where we can run Copilot commands in the context of this single specific cell. Let's go ahead and select a / where we can select explain, and Copilot will generate an explanation of this code cell for us. When we run this Copilot command, we can see that Copilot has generated a step-by-step explanation for us in the chat pane. Let's go ahead and take a look. We are starting by importing some libraries in our first 2 lines of the cell. Then we are creating an instance of label encoder and assigning it to the variable lab. We are then converting the Spark data frame to Pandas data frame, assuming that heartdata df clean is a Spark data frame, right? Then we're selecting columns based on data types, all the object columns and all the non-object columns, that is the numerical data. We are encoding the categorical columns, and this is really giving us an idea of what we're trying to achieve with this code cell. We are replacing the categorical values into numerical values and then placing them back in the original data frame. We're bringing everything together on this 6th step. And then finally, we're displaying the first 10 rows. I really like this summary at the very bottom where we are understanding that this code converts a Spark data frames to Pandas data frames, encodes the categorical columns into numerical values, and then combines the categorical columns with the numerical columns to form a new data frame. Let's go ahead and run this code cell now that we understand better what it is doing. However, we see that we have an error in running this code cell. We could go ahead and read the error, but let's just imagine we're not well versed in Python and we are not sure what is going on here. We can use our next command, which is fix, and Copilot is going to take an attempt at fixing this error that occurred when running the cell. We can see that when we ask Copilot for a fix, it is going to give us a side-by-side comparison of what has changed. If we scroll on this right-hand side, we can see a comment here where Copilot has fixed a typo, adding a dot before select the types. And we can see the dot that is here that was not on this line number 5. It has added some spaces, some blank lines, so that makes it a bit harder to see, but it's still a side-by-side comparison. Let's go ahead and accept these Copilot fixes. We will run this code cell once again, and we can now see that the code cell runs with no error, and we see we don't have any more categorical variables. It is all numerical. And now we're finally ready for what we have been trying to attempt since the beginning of this demo, which is to train a machine learning model. Let's go ahead, generate a new cell, and again, use the chat magic to indicate Copilot that we want a natural language output here. We're asking Copilot, with df ready being our final version of the data, what machine learning models do you recommend to predict the likelihood of heart failure? Explain in plain text, do not create any code. We can see that Copilot is giving us this explanation where we see all our features are fully numerical, categorical data has been labeled encoded, and missing values have been dropped. We are in a good position to apply standard machine learning algorithms for classification. There are different machine learning models. In the first case, we have logistic regression, where we can do binary classification like heart disease prediction. So basically, are we having heart disease? Are we at a risk of having heart disease or not? And Copilot is telling us that this model offers interpretability and is robust to multicollinearity if you standardize features. If we want a bit more of information into these different features, we can continue the conversation with Copilot, but it's also giving us a couple other examples, such as a random forest, a gradient boosting machine, support vector machines, and neural networks. It is also giving us some general advice, telling us to always start with a simple linear model as a benchmark, and then that we can use other models such as random forests or gradient boosting machines for this healthcare-based data. So it's really taking a look at what is our current context and how it can give us some helpful advice instead of in a more general note, right? It is also giving us a special note because you're predicting an outcome related to heart failure. This is supervised classification task. The most important considerations are predictive accuracy and interpretability. And this is something that we're going to get into after we actually train the model. Make sure to evaluate your models using appropriate metrics such as accuracy, F1 score, ROC, AUC, and precision recall, especially if the classes are imbalanced. Okay, now that we are satisfied with the explanation that Copilot has given us, let's go ahead and creating a new code cell. We will use the code magic in this case, and we will ask Copilot to, based on the previous output, train A, and we will pick the very first one, logistic regression machine learning model. We can see also we have some Copilot recommendations here. In this case, it's not very helpful, but if we're writing our own code, this Copilot completions is also something that we can leverage. We can now see the code that Copilot has generated. We see Copilot importing some different libraries from scikit-learn. We can see Copilot dropping the target variable and splitting into training sets. We can see all the comments giving us explanations on what is happening. Then we see Copilot feeding a logistic regression over training data, and then predicting on the testing data set, and then finally printing the accuracy and classification reports. Let's go ahead and run this code. Now that this code cell has finished running, we can see the results. We see that we have a single experiment run, and we see some of our metrics here, our accuracy, our precision, recall, F1 score. And then let's go ahead and ask Copilot to generate an ROC AUC score for this model. Copilot has now generated this code cell where we can take a look at the ROC AUC score of our model. We can see it is 0.93379, but we are not very well versed on this. We're not sure what this means. Is this good? Is it bad? So we can go ahead and ask Copilot for our specific use case. Is this a good ROC AUC score or is this not a good? So we will again enter another chat magic, and we will ask Copilot to tell me more about the ROC AUC score. What does it mean? Why is it significant? In this case, is it good or bad? And we can see Copilot's explanation here, really giving us insights into what the ROC AUC score means. It is a metric to evaluate the performance of a binary classification model, such as our logistic regression model for heart disease prediction. And we're testing the true positive against the false positive. So we have a bit more of an explanation here. Then we can jump into why is it significance. It is a robust measure that is insensitive to class imbalance, unlike accuracy, and it also reflects the model ability to distinguish between the two classes. And we can dive a bit more into that if it is interesting, but I think the most important section is here. Is it good or bad in our case? ROC AUC values range from 0.5, no discriminatory power, just like random guessing, to 1.0, perfect prediction. In our case, the ROC AUC score is approximately 0.93. It is considered very good. It means that the model distinguishes well between patients with and without heart disease, and the model is likely in making useful, reliable predictions. So in this point, we have reached a moment where we have a model that Copilot is telling us it is a useful model, so we can go ahead and use this in production if we wish. In this demo, we have explored all the different aspects of machine learning and training a model with the help of Copilot. We've started from the very beginning where we had a data set that we weren't sure what data it contained, and then we took a look at the different columns included, the different distribution of the data. We cleaned up the data. We inputted some other code that we wanted to understanding of, and we had Copilot help us understand it and fix it and run it. And then finally, we had Copilot help us choose what would be a good example for a model. We trained the model, and then we went ahead and we obtained some predictions from the model, and we were able to determine with the help of Copilot that this is an accurate model. Thank you very much for tuning in for this demo, and hope you enjoyed it.